Welcome back. In this video, I'll be covering logarithm. Logarithms are another way of thinking about exponent. Remember in the previous video on indices, don't forget when you have 2 raised power 3, we said 2 raised power 3, which is something as 2 times 2 times 2 is equal to 8. So, but if I ask you what is such a number that's going to be that 2 is going to be raised to give me 8. We know it is 3 actually, but the process of finding this 3 is through what we call logarithm. In essence, when you have the logarithm of 8 to the base 2 is the same thing as 3. So the logarithm of 8 to the base 2 is the same thing as 3. So meaning a logarithm of a number to a particular base is the power to which such base is going to be raised to give you that number. You understand now? So when I have 2 raised power 3 here, which is 8. So then what is 2 is going to be raised? What is going to be raised to the power of 2 to give me 8 back? So which is this argument? We call this argument. Don't forget this is base and this is our power. So it is known as 3. So if you check these two equations, this first equation is known as indicial equation, if you don't forget. So this second one is logarithmic equation. So you will see that there are relationship in between these two equations, the indicial and logarithmic equations. In fact, so what describe the relationship between them are these 2, 3, and 8. So in general, when I have log n base a equals to x, is a logarithmic form, then I can say my n is what? A raised power h. So this is what? This is an indicial form. So for example, let's say I have example. Simplify log 64 base 4. Let's say number 2, we have log 1 base 10. So solution, number 1, for my log 64 base 4, you can equate it to a x because we want to find a number such that when you raise it to a power of 4, so a number that is going to be what 4 is going to be raised to give me 64. And don't forget, this is my logarithmic equation. Remember the principle I wrote the other time. When you have log n base a equals x, then you can write this in an indicial form. It's going to be n equals to a raised power x. Likewise, this could be written as 64 is equal to 4 raised power x. Then you can rewrite this. You know this, we now have an indicial equation. Don't forget how I explained this when I explained how you can solve indicial equation. You can rewrite this in index form in terms of 4. So then this is something as 4 raised power 3, 4 raised power x. You understand? 4 raised power 3 equals to 4 raised power x. If that is cleared, so then you can equate your base. Then you have that your s is equal to 3. So it means you are going to have 4 raised power 3 before you have 64. That is not difficult, is it? No. So what of the second example? So we have that log 1 base 10. This is not difficult too. So I have log 1 base 10. You can equate it to any variable. Don't forget this is a logarithmic equation. So you can convert it to an indicial equation. Don't forget your rule, the one I wrote the other time, your log n base a equals x. The same thing as n equals to a raised by x in indicial equation. So that's the equation showing the relationship between the logarithm and the indices. So then this one is going to give me 1 equals to 10 raised per y. Also, you can rewrite this one in an index form in terms of 10. That's 10 raised per 0, 10 raised per y. So if you equate the base, it implies your y equals to 0. So meaning that you are going to raise, 0, you are going to raise 10 to be to the power of 0 to give you 1. So you can see the relationship there. So that is when we are talking about the logarithm is another way of thinking about the exponent or your power. Before I conclude this video, let me inform you, let me explain that we have special logarithms. Special logarithms. What do I mean by special logarithms? So you will observe that the base of the log can have many values. For example, I can have log 8 base 2, and even in the example I gave to you, I have log 64 base 4, log 1 base 10. You can see that this log is in base 2, this one is in base 4, and this is in base 10. You can have different types of bases, you understand that, but of all these bases, there are two specials of them. In fact, most of your calculator have buttons for these two special case of logarithm. The first one is what we know as common logarithm. Common logarithm. So common logarithm is the one in base 10 when you have a log in base 10. You understand now? And this type of logarithm can be written without the base on it. For example, if I write log 100, so that is telling me that this log is having a base, but since it is a common logarithm, so it's a logarithm in base 10, so I don't need to write it. That's the one of the special logarithm. Another one is natural logarithm. We have natural logarithm, so that is whose base is a number e. Example, when I have log e base x, you can see that my e is what? Is base x here. So it is not in the scope of this video. I will have explained what this e means. So, but when you have your base in e, we call it a natural logarithm. And you can rewrite this log e simply as what? Len. So then your log e is ln x. So in essence, when I have ln 50, is same thing as log e, so log 50 base e. That's that. Don't forget your special logarithm. So the common logarithm and the natural logarithm. And don't forget the relationship joining, showing the relationship between indices and logarithm is that when you have your log n base a equals x, that's your logarithmic equation. You can have or generate your initial equation from it. That is going to be n equals to a raised power s. If you enjoyed this video, please don't forget to like, subscribe. If you have any question, put that in the comment section. I will see you in the next video. Thank you.